Hello, and today I'm going to be talking about conservation of energy, and this is lesson 2 of GCSE physics. Conservation of energy. The pendulum in figure 2, which is right here, would probably keep on swinging forever if it was in a vacuum, because there would be no air resistance acting on it, and so no energy would be transferred from any of its energy stores. This would be no net change to the energy stored in the system. Because of this, it would be an example of a closed system. So a pendulum in motion, figure 2 is basically a pendulum in motion, and as the pendulum swings down and towards the center, its gravity potential energy store decreases as its kinetic store increases. As the pendulum moves upwards and away from the center, its gravitational potential energy store increases as its kinetic energy store decreases. A system is an object or a group of objects. Scientists have done lots of tests and have concluded that the total energy of a closed system is always the same before and after energy transfers to the other energy stores within the closed system. So this is a note to remember. Never use the terms movement energy or motion energy. You have to only use kinetic energy. The important result is known as the principle of conservation of energy. It says that energy can't be created or destroyed. Energy can be stored in various ways. For example, when a rubber band is stretched, its elastic potential energy store increases. When an object is lifted, its gravitational potential energy is increased as well. Bungee jumping. When the rope is slack, energy is transferred from the gravitational potential energy store to kinetic energy as a jumper accelerates towards the ground due to the force of gravity. When the rope tightens, it slows the bungee jumper's fall. This is because the force of the rope reduces the speed of the jumper. The jumper's kinetic energy store decreases as the rope's elastic potential energy store increases. As the rope stretches, eventually the jumper comes to a stop. The energy that was originally in the kinetic energy store of the jumper has all been transferred into the elastic potential store of the rope. So as you can see here, this is a diagram of the experiment, the bungee jumping experiment, and basically it's a test to see what I've explained in this paragraph. And after reaching the bottom, the rope recoils and pulls the jumper back. As the jumper rises, the energy in the elastic potential energy store of the rope decreases, and the bungee jumper's kinetic energy store increases until the rope becomes slack. After the rope becomes slack, and at the top of the ascent, the bungee jumper's kinetic energy store decreases to zero. The bungee jumper's gravitational potential energy store increases throughout the ascent. The bungee jumpers doesn't return to the original height. This is because some energy was transferred to the thermal energy store of the surroundings by heating as the rope stretched and then shortened again. Key points to remember. Energy can't be created or destroyed. Conservation of energy applies to all energy changes. A closed system is a system in which no energy transfers take place out or out of or into the energy stores of the system. Energy can be transferred between energy stores within a closed system. The total energy of the system is always the same, before and after any such transfers. So if you'd like to continue, we can go on to the noise questions. So I would recommend you pause the video and try these out just to see if you've understood. So I'm going to be showing you the answers in 3, 2, 1. So I hope you understood and thank you for listening. Bye.